When it comes to actually booting the Linux kernel, there are a lot of problems that need to be solved. And it's sometimes sort of like a chicken and an egg scenario. You have to do one thing, but you can't do that thing until the other thing is done. And what do you do first and how do you do it? It can be really confusing. But basically, we want to get the full kernel with all of its modules running. So the boot process is very complicated and it might seem overcomplicated, but the issue is to try to get the kernel running and then allow it to access the modules that are stored on the hard drive on your system. And it ends up being, like I said, fairly complicated. And if I'm honest, I've been a system administrator for over 20 years. I've passed lots of certification tests, and I have never fully understood every step of the process of booting the kernel. So you're going to be like the king of the next nerdy party that you go to, because you're going to know all the Trivial Pursuit answers when it comes to Linux kernels. So let's look and see what the boot process actually is, and then I'll show you on a system where those files live. So I have sort of a little flow chart here. Now, a lot of these steps we probably are already familiar with. First, the computer either has BIOS or UEFI, and that's the hardware on the computer which looks for something that Grub or Grub2, it's one or the other here, will provide. And then that boot code of, that Grub uses points us to the kernel. Now, this is the stuff where it starts to get a little, not confusing so much, but complicated. It's almost like this fine dance that has to be done. Now, what the process is normally is we have the actual Linux kernel itself, which is a file, one file, and it's called VM Linux. Or you probably currently see it called VM Linux with a Z. And the only difference here, these are the same file. The only difference is that this is compressed, right? The Z means that it's compressed. So it's just a space saving method. So usually we use VM Linux just to save some room on the system. And then this is the kernel itself with no modules, right? So there's no modules. This is just the base kernel. And then once the kernel boots up, it will mount all the file systems, and then it will have access to all of the modules that it needs to insert to make things work, like, your USB mouse and your keyboard and your monitor and your video card. All those things are modules that are loaded into the kernel. They're not part of the static kernel, right? I mean, we could build this huge kernel that includes everything, but that's just a waste of resources. And so we have this stripped down kernel that has just enough stuff to make sure that we can mount the file system so that it can have access to all of its modules and then become the full running kernel on our system. There's a few problems. What if this full kernel and all the modules, so basically what if all the modules here are on a file system that this stripped down kernel doesn't know how to mount, right? It's like, well, I don't know how to get onto a RAID device, or I don't have any idea how to mount this fancy new SSD drive that you put into the PCIe slot or something. Well, that's where initrd or init RAM disk comes into play. This is just enough information, like module information and driver information, to be able to have the Linux kernel access the file system so that it can get to its modules. So rather than make, a custom, a bigger kernel for every specific system, what we've done is we have a generic stripped down kernel, and then this initrd has the stuff we need in order to load the modules by mounting the hard drive, or whatever we need. Maybe this is stored on a network drive, so we have to have the NFS stuff in order to mount a remote disk on the computer so it can access its modules. So this is just like the temporary staging area for kernel stuff that we need, and this is kind of inserted right into this running stripped down kernel. Okay, now I want to mention this because a lot of people confuse the init RAM disk with the init RAM file system. And they seem similar conceptually. They are fairly similar conceptually, except that the init RAM FS is actually part of the actual kernel itself. It's part of this VM Linux or VM Linux kernel. And this is, just like it says, it's a file system that it creates and mounts in RAM. And I want to mention this tool, even though we're not going to go into it much. Dracut is a tool that has made this extremely generic using UDEV and stuff like that, so that it's very flexible. But this is basically the tiny little file system that the Linux kernel uses in order to do what it needs to do to get to the point where it can load the full kernel by loading modules. So initram fs is a file system that it loads into RAM, but that's part of the kernel itself. This initrd is a RAM disk that is mounted alongside of the kernel that allows it to get to the point so it can use the full kernel. Initram disk is not used after the system is booted up. This is just like a temporary staging ground to get to the full kernel. Wow, that was a lot of information, but it's really fairly straightforward when you see why it's doing all of those complicated things. Now, I want to show you really quickly some of the files that we talked about. So here I am inside Ubuntu, and this is the boot folder, and we can see we have, here's the initram, sure enough, and this is, I have a couple different kernels in here. There was an update, but the kernel numbers are listed here. But here's the initram disk, and here is the actual kernel file itself. There's a couple other files. The system map actually tells the kernel where on the file system all of its modules live. And then config, this is the configuration file when the kernel was actually compiled. So if you want to see the options that were used there, but those are the main files that are on the system. One other thing I want to show you is this system.map tells the kernel to look in lib modules and then the name of the actual running kernel, and inside there is where you'll see the actual different modules. Okay, and this is where the modules that are going to be loaded in to get that full kernel live. So that's the basics of starting a Linux kernel on your system. Now, I know we covered a lot of things and a lot of terms and a lot of concepts, but they should make sense once you go through that flowchart of what's happening and why it's happening. And in the end, which comes first, the chicken or the egg? Well, it depends on what you need to do, right? If you need an egg, then the egg comes first. If the chicken can handle it on its own, no eggs are needed. I hope this has been informative for you, and I'd like to thank you for viewing.